Good evening. Good evening, Niranjan and Sandhya.
Good evening, sir.
How are you guys?
Fine, sir.
Fine, sir. How are you, sir?
Yeah, fine. Last class, till what we done, man? We completed defects of eye and refraction of the prism started? No, no?
No, sir. You have completed up to the effects of I, sir. You have completed it.
Okay, okay. Try to complete rest of the things today. We'll wait for others for a few minutes.
Good evening, sir.
Good evening, Ovia. How are you?
I'm doing good, sir. How about you?
Fine.
Good evening, sir.
Evening. Shall we start class? We'll wait for a few minutes. Still, who is Nirupama not yet joined? Hamsini joined now. Yes, we'll wait for a few minutes. I think Nirupama. Any exam happened? Chemistry?
Yes, sir. We had chemistry
We had
test.
test
Chemistry
notes, sir.
test, sir.
Okay. We'll wait for a few minutes. Nirupama is trying to upload the paper, it seems. We'll wait for a few minutes. Yeah. Yeah, we will start the class. In the last class, we discussed. 1 second, guys. Still, I'm able to turn the host. Everyone can able to see the screen?
Yes, sir.
Yeah. So today concept, what we are going to discuss is it's actually applications of light. Applications of light. Applications of light in the sense the natural consequences of light ray. Natural consequences. What are the things we are going to discuss in this? The first one is, see, everything almost will go with the animations and we'll discuss there. And we are having only theoretical point of view. Whatever thing today we are discussing, the same thing we are going to discuss in +2 as the major topic. In 12th standard, whatever thing we are discussing, these are the things we are going as a major topic. Out of 70 marks, around 18 to 20 marks will come from this light. The first one is refraction of light through prism. Of light through prism. If the glass object is like a prism, it's a triangular prism. The glass object is like a triangular prism. If light passes through the triangular prism, how it will behave? So that we are going to discuss here. Now the next one is dispersion of light. The dispersion will happen generally when it is passing through any curved surfaces or different kind of geometrical shapes. Example, like sphere kind of lenses, or particularly in prisms we are going to discuss. So dispersion of white light by a glass prism. From this only we are going to discuss how the primary rainbow and secondary rainbow will form. The third one is what causes the dispersion, and everything we'll discuss here. And everything is theoretical point of view, only ray diagrams we are going to discuss here. More than that we are not going to discuss. The higher level we are going to discuss in +2, which already discussed. A recombination of white light, that is also part of the prism. And atmospheric refraction, some natural phenomena based on the refraction. Tyndall effect, scattering of light, and its applications. Why twinkling of stars. Each and everything behind these natural consequences, we are having some science that we are going to discuss. First, we will start the class with respect to the refraction of light through prism. Here we are having what is the meaning of refraction of light through prism and what is its ray diagram, and different angles names and different rays names only we are having the part of the syllabus. And formula for the angle of deviation is also required for us. How it will come and all that doesn't matter for us. See, we will start with this video. After this, we'll go through this one. Guys, you'll able to see the screen properly?
Yes, sir.
If you're unable to hear the audio, you let me know. You
Refraction through glass prism. Let ABC be a glass prism. BC is the base of the prism and AB and AC be its two refracting surfaces. PQ is the incident ray, QR is the refracted ray, and RS is the emergent ray. When light ray enters the prism, it bends towards the normal. When light ray comes out of the prism, it bends away from the normal. Angle through which light ray bends from the direction of incident ray when it comes out of the prism is called angle of deviation. Angle of prism is the angle between two lateral surfaces. Angle of prism A equals R1 plus R2, where R1 equals angle of refraction inside the prism, R2 angle of incidence inside the prism. Another relation between angle of prism A, angle of deviators that is D, angle of incidence I, and angle of emergence E is given by A plus D equals I plus E. Dispersion of light. The splitting up of white light into 7 colors on passing through transparent medium is called dispersion of light. The prism produces deviation in light wave. The angle of deviation produced by a prism is given by D equals n minus 1 A. When white light is incident on a prism, then angle of deviation is different for different colors. When the dispersed white light is made to fall on a white screen, we get a 7-colored band of light. This colored band is called a spectrum. Formation of rainbow. Rainbow is produced by dispersion of sunlight by tiny raindrops present in air.
See, this video covers 3 different topics. Each and every topic we will discuss elaboratively now again. You see one more video, little bit higher level. Any doubt in this, please let me know, guys. What are the mathematical formulas they are discussing? Forget about those things.
If a prism is placed and a narrow beam phenomenon is
This
called
we will discuss when dispersion of light comes. Now we will see refraction. Refraction of light means, see here, if I'm taking a triangular prism, I showed you how the prism looks. You can see in labs also. If you see the base, so this is the AB is one refracting phase and AC is another refracting phase, and BC is called base of the prism. If I look like this, it will be like this. It will look like this. So I'm not drawing the 3-dimensional diagram. So here. So for this, the red color line shows the normal for the AB, because the light rays, everything will deviate with respect to normal only. We'll discuss. So this angle is 90 degrees. And for AC, another red color line, this is a normal. So N1 is a normal at AB, N2 is a normal at AC. Both will meet at a point. You can take D. Now, if a light ray is incident, so I'm taking a different color for incident ray, the green color ray. If there is no prism, this light will go like this. If there is no prism, the light will go like this. There is no prism, the light will go like this. So now this is air, this is glass, and it is air. When the light ray is entered at a point E here, this light is called incident ray. So what will happen if the light ray is entering from air to glass? See, this medium is fully, ABC is completely glass. It is entering from air to glass. What will happen, guys? If the light ray is entered from air to glass, what will happen? The ray will bend towards the normal or away from the normal? Sandhya, Ovia, if light ray enters from air to glass, in which side it will bend?
It bends towards the normal, sir.
Towards the normal. See, the red color line shows it towards the normal. It will bend towards the normal. So instead of going like this, it will bend towards the normal. So it will bend like this. So again, the F, suppose this is F is the incident ray, EF is the incident ray inside the prism. That ray we won't call as an incident ray inside the prism. EF is called refracted ray inside a prism because it is refracted. So when it touches the F, and now it is coming out of glass to air. When it is coming out of the glass to air, how the light ray bends? Suppose it should go like this. but actually it is coming from denser medium to rarer medium. It will bend away from the normal. Away from the normal means this arrow mark shows the away from the normal. So I'm going with a blue, not blue color line. I will go with a pink color line. See this one. The light ray which is coming out from AC is called emerged ray. The angle between normal at this surface and emerged ray is called emergence, angle of emergence. The angle between incident surface to the normal at that surface is called incident angle. These are called refracted angle. R2 is the incident angle at AC. R2 is the incident angle at AC. See here, if I'm observing from here, this ray is coming somewhere from here. See, there is a pink line and green line. The green line is actual ray of light. This is actual path. The pink line is deviated path. The angle between actual incident ray and emergent ray, generally represented with a delta or capital D. This is called angle of deviation. See, AB is one refracted surface and AC is another refracted surface. The angle between AB and AC is called, or the angle between both the refracted surfaces are called angle of prism. Is called angle of prism. Why it will deviate like this? Because of purely its geometrical shape. Because one normal is in this direction, another normal is in this direction. Because this only lateral shift won't happen here. Here it won't bend. It will completely deviate than its original path. So because of one face is in one direction, another face is in another direction. So in this case, it will bend towards the normal. When it comes, it will bend away from the normal. So further bending, 2 times it will bend in same direction. Because of this, the incident ray is completely deviate than its original position. So here, our scope of subject is, they will ask you to draw the ray diagram or they will ask you to explain the different angles. What are the major angles? If I see here, in major rays, incident beam, this is an incident beam at AB face, and EF. Suppose if I'm taking EF is a refracted ray which is inside the prism, and F, the light ray which is coming out of AC is called emerged beam or emerged ray. So the angle between the normal of AB and incident ray is called angle of incidence. The angle between the emerged ray and emergent phase, that is called AC, is called angle of emergence. The angle between the refracted ray to the normal at AB is called refraction angle. This R is called incident angle for AC. The angle between both the faces of the prism is called angle of prism. Here he took the 60 degrees. So these are the different angles and different rays when a light ray suffers under refraction through a prism. Is it clear, guys? Anything want to discuss? How to find out the angle of deviation and all we discuss, and there is a derivation for this we'll learn in +2. Using your geometry only you're going to do. Nothing is there. What other thing you've done in 9th standard and 10th standard geometry, using that only we can take. We'll take the triangles like this one. We'll take the triangles. This is R1, this is R2, this is A, and this is I, this is E. The angle of deviation, if a light ray passing through a prism, D is equal to angle I plus angle of incident plus angle of emergence minus angle of prism. This is the formula you have to keep in mind. So how this formula will come, we'll discuss in grade 4. It's like a geometry, basic geometry. From the basic geometry we are going to discuss. This is only the overview of refraction of light through a prism. Is it clear?
Yes, sir.
Now, dispersion of white light by a glass prism. we already saw the video. Dispersion of white light means if a white light passes through a prism, it will split into several colors. It will split into several colors. That not many. It's a limited. There are only 7 colors it will split. The splitting of light when passes through a prism, a white light is passing through a glass prism, and after emerging, it will split into different colors, is called dispersion of light. Dispersion of light. We'll see a small video related to dispersion of light. Both refraction of light and dispersion of light we'll see again. Let's see. After that, if you are having any doubts, please let me know.
Atmospheric refraction, twinkling of stars is.
So this is application. This is not what I'm talking. Sorry. This is dispersion of prism and combination of white light. We'll discuss both here.
Dispersion of white light by a glass prism. You must have seen and appreciated the spectacular colors in a rainbow. How could the white light of the sun give us various colors of the rainbow? Before we take up this question, we shall first go back to the refraction of light through a prism. The inclined refraction surfaces of a glass prism show exciting phenomenon. Let us find it out through an activity. If a prism is placed in a room and a narrow beam of white light is allowed to fall on one of its refracting faces, what do you observe? It is found that light coming out from the other face of the prism is split to 7 colors. What are the 7 colors that you see on the screen? The various colors seen are violet, indigo, blue, green, yellow, orange, and red. This phenomenon, the splitting of light into its component colors, is called dispersion of light. The band of the colored components of a light beam is called its spectrum. Why does this happen? The acronym VIBGYOR will help us to remember the sequence of colors. We have seen that white light is dispersed into its 7 color components by prism. Why do we get these colors? Different colors of light bend through different angles with respect to the incident ray as they pass through a prism. The red light bends the least, while the violet the most. Thus, the rays of each color emerge along different paths and thus become distinct. It is the band of distinct colors that we see in a spectrum. Isaac Newton was the first to use a glass prism to obtain the spectrum of sunlight. He tried to split the colors of the spectrum of white light further by using another similar prism. However, he could not get any more colors. He then placed a second identical prism in an inverted position with respect to the first prism. This allowed all the colors of the spectrum to pass through the second prism. He found a beam of white light merging from the other side of the second prism. This observation gave Newton the idea that the sunlight is made up of 7 colors. Any light that gives a spectrum similar to that of sunlight is often referred to as white light. A rainbow is a natural spectrum appearing in the sky after a rain shower. It is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. A rainbow is always formed in a direction opposite to that of the sun. The water droplets act like small prisms.
Sorry guys, I will discuss the rainbow concept in some other video. So you got it. What is the meaning of dispersion of light? Guys, Niranjan, Sandhya, everyone? What is the meaning of dispersion of light? You understood? Any
Yes,
doubt?
sir.
See here. We'll discuss a little bit more. Why dispersion will happen? Sorry, somebody is asking something.
Sir, the separation of light into different
Separation of white light when passes through a glass prism.
classes.
Why? What is the exact reason? What do you understand from the video? What is the reason? Why it is not dispersed in atmosphere or in general? Why it will disperse? The dispersion will happen only when it is entered in a medium, like either raindrop or in a glass prism. From the video, anybody can give the idea of why it is. Yes, I'll go back to this one. See here, the white light is combination of 7 colors. That means these 7 colors having 7 different frequencies or 7 different wavelengths. Not frequencies, wavelengths. In case of atmosphere or vacuum, all 7 colors will travel with the same speed approximately. That's the reason we are unable to see the separation of the colors. But when it enters into a medium which is a refractive index is greater than vacuum, because vacuum is the least refractive index of the medium, but the glass is having a different refractive index. When it enters into a different refractive index, because of its different wavelengths, each color will travel with each color of light will travel with different velocities. Whenever it is traveling with a different velocity, the refraction angle is also different. The refraction angle is also different. So what happens? Because of its what will happen in this case? Because of different speeds, different colors will bend in a different angles. So first, the violet light will bend more and the red light will bend less. Even the same thing will happen in the second surface also. That's the reason when it is entering, it will enter as a single ray, but when it is emerging, it will emerge as a different colors because of the inside the prism, because of its refractive index, the speed of the light is different for different wavelengths. Automatically, in case of air, all the wavelengths having the same speed, but inside the prism, different speeds. If it is a different speeds, different refraction angles we will get. That's the reason all the colors will split once it is entered. This is actually main reason for our level. Even your 10th standard also you can see. The wavelength is directly proportional to velocity, and velocity is directly proportional to 1 by deviation. So wavelength is directly proportional to velocity and inversely proportional to deviation. More wavelength, less deviation. That's the reason red color is having the more wavelength. It will deviate very less. And violet color is having less wavelength. It will deviate more. This is the actual reason, cause of the dispersion. So simple, you can express in terms of velocities. When compared to a vacuum or air, the velocities of the different colors are much differ inside the prism. That's the reason we can see the 7 colors are splitting together. So if we keep another prism in this path, like this, inverted, which will allow all the colors are passing, this all colors will rejoin and all colors will rejoin. And it will form a single white light. This is called recombination of white light because the entering itself, each and every color is entering separately. Here, each and every color is entering separately because of the first prism is dispersing and the second prism is combining. That is called recombination of white light. Recombination of white light we will get only by keeping the 2 different prisms one prism is at one position, another prism is inverted to the initial prism. Then only you can get the recombination of white light. This is what actually happens when a white light passes through a glass prism. Is it clear, guys, what I'm saying? Any doubt from the glass prism deviation, like a dispersion of the prism?
No doubt, sir.
So now we will see the applications. The first one is rainbow. The dispersion of light can able to explain the phenomenon of rainbow. We'll see how the rainbow will form here. Different phenomena. Not only one phenomena we are having, a rainbow, Tyndalling effect of these stars, and twinkling of stars, Tyndall effect, scattering of light. What is the application? What is the meaning of scattering of light? We will see here.
Scattering of light, emitting electrons, in turn, more than blue light drops. Sometimes, forms of bows light. The removal of blue, therefore, sun looks for arcs too.
Sorry guys, we will
sunshine.
see the rainbow formation. The rainbow formation is can be explained by the concept of dispersion of prism. After that only we'll go for the scattering of light. We'll play the remaining video after that.
2. Rainbow. The colored concentric arcs, or the spectrum of white light from the sun in the forms of bows, when the sun shines on raindrop during or after the rain, is called a rainbow. The reflection and refraction by water droplets causes the formation of a rainbow. To see a rainbow, you must have the sun to your back, while you look towards a cloud of water drops. Sometimes two rainbows are seen. The inner rainbow is called primary rainbow and the outer one is called secondary rainbow. The primary rainbow is brighter than the secondary rainbow. Primary rainbow. The primary rainbow has violet color on the inner edge and the red color on the outer edge of the rainbow. It is formed due to two refractions and one total internal reflection of the light incident on the droplets. When white light from the sun enters a spherical raindrop, the light is refracted or bent. The different colors of light are bent through different angles. After total internal reflection from the back inner surface of the drop, different colors of light are again refracted as they leave the front surface. Diagram shows how red and violet rays are bent by spherical raindrops and reflected off the back inner surface. Violet is bent the most and so reaches the observer's eye from droplets lower in the sky. In other hand, red is bent the least so that it reaches the observer's eye from droplets higher in the sky. Other colors of light are seen at intermediate angles. The result is that top of the rainbow appears red and the inner arc appears violet. Diagram shows the path of light in a spherical water drop. A ray of light from the sun is incident on the spherical raindrop at angle of incidence of theta. The ray is refracted along AB, making an angle of refraction theta dash. Note that theta dash is also the angle of incidence and internal reflection on the back inner surface of the raindrop. Also theta dash is the angle of incidence on the existing point from the raindrop. Because of the symmetries involved, the ray exists at an angle theta. The angle between the incident ray and the existing ray is phi. See the diagram. Secondary rainbow. The secondary rainbow has red color on the inner edge and violet color on the outer edge of the rainbow. It is formed due to two refractions and two total internal reflections of light incident on the droplet. Note that the order of colors of the secondary rainbow is just reverse of that of the primary rainbow. This is due to the fact that light enters from the bottom of the drop
Class lo unnaru.
and not from the top, as in the case when a primary rainbow is formed. Since light suffers two total internal reflections, more light is absorbed and the secondary rainbow is always fainter than the primary rainbow.
Okay, మరి మ్మ్. 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 సరే 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 నేను క్లాస్ అయిన తర్వాత డీటెయిల్గా మాట్లాడతా సరేనా Guys, is it clear how the rainbow formation, what is the primary rainbow? It is more than enough. Actually, that much of is not required. But for knowledge purpose, I'm giving what is the primary rainbow, what is the secondary rainbow. Is it clear?
Yes, sir. Clear, sir.
Yes, sir.
Yeah, now we'll see the scattering of light. It's very simple. Scattering of light means the atmosphere is made up of small tiny particle, dust particle, water particles, anything. The light will come in the wave format, like this. The wavelength is if the wavelength of the light and the particle, a dust particle which is less than the wavelength of the light, when it is collide with this particle, this light will scatter. This light will scatter means what will happen? If it is before collision, if it is having frequency n1, after collision, the frequency of the light will change. Whenever the frequency of the light will change, automatically it will split into different colors. It will scatter into different colors in all directions. So this is called actually scattering of light. It will be easy to understand with an like we can perform the experiment in our house also, scattering of light and Tyndall effect. But you just go through the animation only because of we are having theoretical, what is the definition of the scattering of light, what is its natural consequences. Let's see. The same video, the beginning part will explain the scattering of the light.
Some natural phenomena due to sunlight. A. Scattering of light in atmosphere. When a beam of light falls on an atom, it causes the electron in the atom to vibrate. The vibrating electrons, in turn, re-emit light in all directions. This process is called scattering. Earth's atmosphere contains air molecules and other tiny particles. When light from the sun passes through the atmosphere, it gets scattered by the large number of particles in the atmosphere. According to Rayleigh law, the intensity of scattered light varies inversely as the fourth power of the wavelength of light. 1. Blue color of sky. Since the wavelength of blue color is smaller than the wavelength of red color, lambda b less than lambda r, scattering of blue light by particles in Earth's atmosphere is very large. For this reason, we see a blue sky. All the violet light is scattered more than blue light. Our eyes are not very sensitive to violet light. 2. Clouds are white. A cloud is composed of large dust particles and water molecules. These large-sized particles do not obey Rayleigh law of scattering. Therefore, all colors or wavelengths are scattered equally. The overall result is a white cloud. 3. Sun looks reddish at sunset or sunrise. At the time of sunset or sunrise, the sun is near the horizon as shown in diagram. The rays from the sun must travel more kilometers through the atmosphere than at noon. Therefore, more blue is scattered from the sunlight. The removal of blue leaves the transmitted light more reddish in appearance. Therefore, sun looks reddish at the sunset or sunshine. 2. Rainbow. The colored concentric arcs
I
or the
think
spectrum
we
of white.
done rainbow. Yeah. So some more applications. If there is anything a little bit elaborative video, we'll see here.
Michael and Jeff are walking on a late afternoon when the sun is about to set. They notice that the sky has started to change its color to red. They wonder what's happening to the blue sky. Our planet Earth is surrounded by a layer of gases called the atmosphere. When sunlight enters the Earth's surface, it is deflected from its original path by dust particles and gas molecules. This process is called light scattering. The amount of light that is scattered depends on the wavelength of the light. The wavelength of colored lights decreases from red light to violet light. The shorter the wavelength of the light, the more it will be scattered. Blue light, which has a shorter wavelength, is scattered more than red light in the atmosphere. In fact, the shorter the wavelength of the color, the more it is scattered in the atmosphere. The distance that sunlight must travel through the atmosphere before reaching our eyes also affects the amount of light that is scattered. This distance depends on the time of the day. During sunrise, when the sun is close to the horizon, the path of the sunlight in the atmosphere is the longest. At noon, when the sun is high in the sky, the path of the sunlight in the atmosphere is the shortest. During sunset, when the sun is close to the horizon, the path of the sunlight in the atmosphere is the longest. At night, the sky is dark because sunlight cannot reach the observer. The occurrence of blue sky during the day and red sky during sunset is due to the scattering of light. During daytime, blue light scatters more than red light in the atmosphere, and due to the shorter distance traveled, it is able to reach our eyes before being completely scattered away. As a result, we can see blue light coming from all parts of the sky, causing it to appear blue. During sunset, sunlight travels a longer distance in the atmosphere. This means that most of the blue light will be scattered, while some red light will reach the observer's eyes, making the sky appear red.
Guys, is it clear how to explain why the sunlight is reddish and the sun is reddish in the sunset and the sunrise, and the blue color in daytime? The sky is blue color. I think hope you are clear how you can explain from the scattering of the light. Is it clear? Any doubts? Nirupama?
No, sir.
Is it clear? Anything want to discuss separately? I will explain. Next, I'm going for the Tyndall effect. Tyndall effect means there are some liquids which will show the light ray passing through the liquid. The refraction we can able to observe from some liquid. Some colloidal solution, it is not possible to observe. This is called Tyndall effect. Let's see what is a Tyndall effect. From this, you can see an experiment if you are having the laser light, like a toy light. Take a water, if you send the light through water, you can able to see, but mix a little bit sugar solution or soap solution, you try to pass the light, you can see the Tyndall effect of the light. All these things actually we can learn easily only by activities.
Tyndall effect. Objective: to learn the concept of Tyndall effect. The Tyndall effect, named after physicist John Tyndall, involves the scattering of light by finely suspended particles in something such as in colloid. This effect is also referred to as Tyndall scattering. Let's demonstrate the Tyndall effect. We'll begin by filling all 3 beakers with the distilled water. In the first, we'll leave just the water. In the second, we'll dissolve a spoonful of sugar. And in the other, we'll stir a few drops of milk. First, we'll shine through the beaker containing only the water. Although we cannot see the light beam as it is passing through the water, we'll be able to see it as it emerges unchanged from the other side. Now we'll shine our laser through the second beaker containing the sugar solution. Once again, we cannot see the beam as it passes through the solution, but we are able to see it as it emerges from the other side, again unchanged. Finally, we'll shine our laser through the third beaker, which has milky water. In this case, we are able to clearly see the light beam as it passes through the liquid. This appearance of a light beam passing through a liquid is the result of Tyndall effect. What is happening to the light beam? Let's take a closer look at what's in each beaker so that we'll have a better understanding. In distilled water, any particles are too small to obstruct the path of light as it passes through, meaning we won't be able to see the beam. A solution, such as a sugar solution we made, is a homogeneous mixture made up of only one phase. In this form, the solute, in this case the sugar, will dissolve in the solvent, in this case the water, and take on the characteristics of the solvent, meaning once again we won't be able to see the light hitting anything. A colloid, however, has two phases: the dispersed phase, which is the milk particles, and the dispersion medium, which is the water. In the colloid, light will scatter in different directions due to the dispersed particles. But in water and in true solutions, such as a sugar solution, it will pass through without being scattered. The Tyndall effect is used in identifying whether a liquid is a solution or a colloid. Summary. The Tyndall effect involves the scattering of light as it passes through a colloid. True solutions do not exhibit the Tyndall effect.
Is it clear, guys? What is the Tyndalling effect? I think you can able to explain by your own. Niranjan, Sandhya, anyone having any doubts?
No, sir.
Yeah, it's the same as refraction of light. Natural consequence of refraction of light till we are having twinkling of stars, advanced sunrise and delayed in sunset. So this is a twinkling of stars. So it will be very clear. Assume there is no dispersion and there is no scattering. This light is passing through the atmosphere. But atmosphere is having the little different density and vacuum doesn't have much density. So automatically refraction will happen when it is passing from vacuum to atmosphere. So what will happen? What kind of illusions will happen? This is only the some natural phenomena based on the atmospheric refraction. The first one is twinkling of stars.
Atmospheric refraction, twinkling of stars. Night sky is very beautiful. It is consist of different objects. Some of them are stars, while others are planets. Looking at the night sky, can you figure out if the object is star or a planet? Yes, you have been learning it from your childhood. The objects which twinkle are stars, and the objects that do not twinkle are planets. The question in today's discussion is, why do stars twinkle? Basically, the reason behind the twinkling of stars is atmospheric refraction. Let's learn how it happens. We live on planet Earth. The atmosphere of Earth consists of layers of air. The particles of air are closely spaced at the surface of the Earth than these at higher layers. That means the density of air is highest at the surface while it goes on decreasing towards the top layer. Now let's talk about a star. A star have its own light. Since they are at far distance from the Earth, therefore looks point-sized and so are treated as point source of light. The light coming from star, that is a starlight, when enters in the Earth's atmosphere, layer by layer, it experiences increasing density and so bend towards the normal at the boundaries between the layers. When it comes to us, we observe the star to be slightly higher than its actual position. Now air is fluid. It has property to flow. So, there are continuous and random variations in every layer of the atmosphere. These changes result in the random change in refractive indices of the layers. So, if refractive indices of these layers are not steady, how will the apparent position of star appear steady? The apparent position changes slightly but randomly. Similarly, because of random changes in refractive indices, the brightness of light coming from star also appears to be changing. The resulting effect of changing apparent position and changing brightness causes star to appear twinkling. Why do planets do not twinkle? The reason is simple. Planets are much closer to Earth. They reflect light falling on them towards us. Since planets are much closer to Earth, they could not be considered as point sources. Large number of rays coming from such objects undergo refraction in random manner. But while reaching at observer, they nullify each other's effect. That means neither the position of planet change nor there is change in brightness of light coming from them. The intensity of incoming light does not change. It remains constant, and so planets don't twinkle. I hope you have understood this concept very well. Thanks for watching this video. Have a look at the range of courses available in.
Is it clear, guys? So based on these examples, anyone can explain why there is a delay in sunset and advance in sunrise? Anyone? Anyone can explain delay in sunset and advance in sunrise? Ranjan, anyone? I'm showing the diagram. From the diagram, at least anyone explain. The logic behind this is refraction only. Refraction due to the atmosphere.
Sir, can I try?
Yeah.
Sir, during the sunrise, the sun is below the horizon. So the atmosphere causes the light rays to bend and we can see the sun
Towards the earth. Because it is entering from rarer to denser medium. See, this is a true position. If there is no atmosphere, this sunlight rays will go like this. What are the red line I am drawing is like this. But because of the atmosphere, what will happen? It will bend like this. See, the yellow color line is bending of the light. But the observer is here. He is looking, the light is coming somewhere from here. This is the apparent position of the sun. But actually sun is here. But he is looking like the sun is at this position. So before entering the origin line, you can able to see the image of the sun because of the refraction of the light through the atmosphere. This is a reason why we can see the advanced sunrise. In same concept we can explain in delayed in sunset also. Anyone can explain the delayed in sunset? Whatever the sun we are seeing in the evening, it is not actually available, but we can able to see. How?
Sir, only the apparent position of the sun will be visible, but the actual position will not be seen.
Okay, see here, even the sun is under the origin line in the sunset condition. So the sunlight is coming like this. But because of the atmospheric refraction, it will refract like this. Even the sunset happens, the observer can able to see the sun's image at this position. So that's the reason we can say the sunset is delayed because of the atmospheric refraction. Atmospheric refraction. Whatever the image we are seeing, it's actually an illusion image or an illusion image, or like it's not actually a real image. It's already sunset happens, but because of the refraction, we can see the light rays coming from somewhere in the sky, which can be visible. That image only we are able to observe. This is only the advanced sunrise and delayed in sunset due to the refraction of the light when it is passing through the atmosphere of the earth. Is it clear, guys? How we can explain? I hope you will explain all the Tyndall effect, the scattering of the light, color of the sun at why it is blue color in the daytime, why it is red color in the morning and evening times. What is the reason behind advanced sunrise and delayed sunset? Refraction through the prism, dispersion of the prism, recombination of the white light. All these things can be explained. Is it possible? Will you explain if I am asking in next class?
Yes, sir.
Yeah. So almost we completed. Almost
Yes,
we're done
sir.
with the syllabus. Nothing is there. But slowly by doing different worksheets, we will recollect. We will do all the revision again. We'll do all the revision again. Is it clear, guys? Shall I wind up the class? We'll do some numericals, some questions in the next class. Most might be next class we are winding up and we'll start the revision again with the different test or a different. I will let you know what is the plan I'm going to take. Is it clear?
Yes, sir.
And what is the portions for your examination? Some examination is happening now. Like, what is your portions?
Subject, sir?
Sorry?
Sir, in school?
In school only I'm asking.
Sir, which subject, sir? Maths or physics? Sir?
Maths, I already got the messages. So physics I'm asking.
Sir, for physics.
Physics only electricity.
Only electricity.
Yes, sir.
Yes, sir.
Raghava sir told any examination for physics?
No, sir.
No, sir.
So I will come with a plan within 1 day maximum. Okay?
Okay, sir.
Yeah.
Okay,
Bye
sir.
everyone. We'll meet in next class. Bye.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.